Okay, I'm gonna go ahead and get going, and people can join when they join, if they join. I want to use today to basically do a little bit of marketing. um, when I was down in San Francisco listening to the Agoric folks making, I have to say, just completely silly claims about the use of JavaScript in order to um, glom onto adoption and network curves uh, um, associated with JavaScript for the purpose of writing significant blockchain logic. And that's just, to me, there's several problems with this. So I want to go through those, the problems with this argument, one step at a time. I've written a little draft, which I'll probably turn into some presentation. Let me go through those points now. The draft has been posted to Twitter. The 4 points run as follows. So again, the idea is that Agoric has chosen JavaScript to try to take advantage of JavaScript's widespread adoption, and they believe that this gives them some advantage over new technologies that address the specific problems of programming state in the blockchain. So there are 4 problems with this. The number one problem is that all technologies, including JavaScript, begin their life cycle facing an adoption problem. And if you go and analyze the what created the widespread adoption of JavaScript, there are basically 2 conditions. Condition number 1 is that JavaScript provided the ability to program UI in the browser. That was its number 1 function. And it turns out that that was highly in demand, and it was lucrative for developers to be able to program UI in the browser. And so they reached for whatever tools were available to do that. And JavaScript was there at hand, and so they reached for JavaScript, and that's what caused the adoption. In general, these are the conditions that you need in order to create widespread adoption. You need to have a capability that is in demand, and that demand is associated with economic reward. So the same thing happened to Solidity, right? People wanted to program blockchain state. Solidity made it possible to program blockchain state, and being able to do so was connected to fairly highly leveraged economic gain. And so we saw a dramatic acceleration in the adoption of Solidity. No surprise, those are the conditions. It's really important to understand, however, that when these narrowly scoped design choices are adopted, it typically costs the industry hundreds of millions of dollars to correct mistakes. So in particular, I mean, the design flaws in JavaScript were well understood. I mean, we knew they were flaws over a decade before JavaScript was conceived. So, you know, it really was narrowly scoped to the point of not even being aware of what we already knew. So there's so many examples of design flaws in JavaScript. But let's just pick one of them. JavaScript, as initially conceived, was without types. And it's well known that if you're going to produce code in production at scale, you need types. You cannot be using humans to write tests that could be completely automated by a compiler. That's just too expensive. And this is why not one, but 3 of the biggest providers browser-based UI, namely, Microsoft, Google, and Facebook, have all produced typed versions of JavaScript for this reason alone, right? And that alone has, in aggregate, cost the industry hundreds of millions of dollars. And that doesn't account for all the time wasted in human hours wasted in writing tests that could have been automatically generated by compilers. Nor does it count all of the time having to go back, find the errors, sometimes egregious errors, that were caused by not having those kinds of capabilities. In Solidity's case, in one day, the industry paid $50 million. And that was the DAO bug. And then there was a slow roll of an agonizing discussion over whether Ethereum should hard fork that took place for a month. Right. So that's just the beginning of the kinds of errors we'll see. And more of them are coming. We've seen more, the parity wallet error and so on. These will cost the industry because of the narrow scope in the Solidity design that doesn't recognize known issues with known solutions. So this idea of reaching for the tool at hand without paying attention to the design desiderata is just a bad idea and needs to be looked at with much more circumspection. But in addition, the real point is that we are undergoing a paradigm shift, right? I mean, now is the time. We're at a juncture in computing that we haven't been at before. And that has to do with the shift from sequential to concurrent. I've made this point over and over again for the last 20 years. Moore's law is behind us. The vast majority of hardware acceleration comes from adding more cores per die, more CPUs per box, more boxes per rack, more racks per data center. That's how you get scale. So if your programming model doesn't support that way of scaling, you're not serving your developers. Likewise, so that's what's happening from the hardware up to the programming model. If you consider from the users down to the programming model, it's a very similar kind of pressure on the programming model. So the programming model is, under the requirements to provide support for tens of millions, if not hundreds of millions of active concurrent users on a 24/7 basis. So if your programming model doesn't support being able to handle that kind of demand, that kind of load, then again, you're underserving your developers. So JavaScript has no explicit support for concurrency. Its execution model is actually sequential. And no amount of event loop programming or futures or any of that stuff is going to address this issue. And in particular, in the case, as I've pointed out over and over and over and over and over again, the mobile process calculi provide concurrency model, but more importantly, they provide the correctness properties, right? So even if you get up to speed, even if your model handles the throughput, it doesn't matter if you're running speed if you're incorrect. In fact, it's better to go slower. The reason Ethereum didn't completely come apart at the seams because of the DAO bug was because at the time they were running at about 7 to 10 transactions per second. If they had been running at Visa level speeds, the 40K TPS, then the DAO contract would have been drained in 1 second. And the result would have been that, the likely the network would have collapsed because people would really understand the nature of these kinds of problems. As it was, Ethereum was operating with a certain modicum of grace because they were moving so slowly. And as a result, the community could consider the problem for a month before they eventually hard fork. As we move into blockchain 2.0 and 3.0, where you do have these high transaction volumes, if we don't have some kind of automated support to catch the kinds of concurrency and security errors that will inevitably be introduced by user level code, those blockchains are completely vulnerable. JavaScript does not have the syntax nor the programming model that allows for static analysis of these problems. If you turn it around, turn this from the negative to the positive, a programming model that does allow for to capture the benefits of concurrency and at the same time provide the ability to catch those kinds of errors will be in the high demand by developers. Right? They will suffer these kinds of errors enough to the point where they reach for tools that prevent the errors. And if you are right there ready to provide them with the tools that will prevent the errors, they will reach for you. Hence, you will overcome the adoption problems. Third point, fintech is constantly adopting new technology. It is well known, if you have done any time with the fintech shops, you know that they are basically on a 2-year cycle retooling. And there are many sociological reasons for that. One of which is they want to keep the top hotshot developers who are constantly in look shiny mode. So they spend lots and lots of money allowing their developers to go try out the shiniest new toys and to retool their entire infrastructure on a regular basis, roughly on a 2-year cycle. And a recent example was when somewhere around mid 2000s, somewhere to 2012, somewhere in that time frame, the market found a love affair with functional programming again. And as a result, the Credit Suisses and the Goldman Sachs of the world all tooled using functional programming, and even new players entered the market using functional programming. So that's when you saw the rise of firms like Jane Street and others of a similar ilk. So it's well known. This is established. It's you can go check it out. Lots of data to show. The fintech is constantly looking at new toys. And so if you can provide them with new toys that are clearly advantageous and fit with the market demand, then they will adopt your tech. They will go play with it. And if they like it, they will then lead the market in that direction. So again, this idea of using old stuff to attract the market is just wrong. The thought leaders will adopt, shiny new toys that really do stuff. And then finally, there's a moral argument. If and the agoric people do know, they say it explicitly, if you know that your solution is suboptimal and you still promulgate it, isn't that just, doesn't that make you culpable? It's like, don't put stuff. It's just like a really simple point. So the conclusion of the draft is it's time to go on a walk on the wild side, in the sense that we need to embrace our nature, and nature is massively concurrent. I've made this point over and over and over again, but there is no tree directing all the trees to clean the carbon out of the air. Instead, all of the trees and all of the plants in general are working autonomously, but in coordination. At least with the trees, we know that they're coordinating through the mycelial layer. This has been one of the most astonishing developments in understanding the biosphere in the last decade or so, is how much the trees are communicating and sharing through the mycelial. So they're working anonymously but coordinating through the mycelial layer. And then if you look inside the tree, you'll discover that the trees are made of cells, all of whom are working autonomously but coordinating with each other. And this is kind of nature's beautiful fractal way of recapitulating this highly concurrent design pattern. So humans, on the other hand, and you can see this in Turing's original paper, humans are sort of hampered by the left brain's sequential language processing, right? So humans think about thinking as if it were sequential. They think about processing as if it were sequential. It's not the case. And we can have a direct experience of it if we spend a little more time in the right brain. So Jill Bolte Taylor has a lovely discussion of this when she talked about her stroke, her experience with her stroke, which left her almost entirely inside her right brain. But you don't have to have a stroke. We all know that it's possible to walk and chew gum at the same time. We also, know that it's perfectly reasonable to have the guitar and the bass and the piano all playing at the same time and not politely waiting for each instrument to finish its sentence. In fact, that's how harmony happens. So if we're genuinely concerned about adoption, the look at how music is adopted. Look at how quickly a new musical genre will be adopted, right? And then go with programming models that allow developers to weave streams of transactions in the same way that DJs weave beats. Those programming models exist. Rolang is one of them. There are others. Go explore those too. But don't waste this opportunity. Don't spend any more time trying to push sequential models because they are doomed. So anyway, that's the argument against this, adoption idea using JavaScript. It is a non-starter and will only lead to more pain and anguish and huge amount of cost to the industry over time. Any questions?
No, that was a good overview.
Cool.
Yeah, I've read this document also earlier today. So yeah, I think it's great because it's very short, very simple and straightforward. So yeah, that's very good.
Thank you.
So how about OSLF? I remember, one of the thing OSLF can do is it can create a type system for, traditional language as well. So can we also give like JavaScript a type system?
Oh yes, we certainly can. But the problem is it's because JavaScript in its programming model doesn't say anything about concurrency. The type system will also not detect anything about concurrency. Right? OSLF, doesn't invent new stuff. Like you get the programming model and it's based on your ability to experiment. And so you think about it, every programming model comes with a notion of observation, a notion of experimentation. So you can all derive a notion of bisimulation from the programming model. And so what the type system says is, well, based on this notion of observation, these are your types. Right? But script doesn't have a way to talk about concurrent observations. So the type system can't say anything about concurrency.
I see. So OSF cannot generate something out of thin air. That's basically the idea, right?
Exactly. Yes.
So there's another question is, as I know, Dan is doing some work to, like a class compiler, so it converts JavaScript into Lowland. So
yes,
what's your take on this?
but this is also so I've done this kind of, it's a sort of Damocles in the sense that, um, uh, you enable people to continue to program in the way they're comfortable with, right? So first of all, think about it. You write in JavaScript, so there's no concurrency in your code. It goes to Rolang, and so the image of your code will still be sequential, right? The compiler, in order to be faithful, will have to pick out sequential execution in Rolang. So you've gotten no benefit from Rolang. And if you tried to go the other way, you'd be forcing JavaScript to take on concurrent behavior, which it has no decent support for. And if you then tried to do the static analysis on the JavaScript side from the concurrency that you shoehorned in, well, the problem is that it's not syntactic; it's all programmed. And that's something, that's you're not going to get a compiler to catch that, right? That's the point of having syntactic support. If you program it as a library, the compiler can't touch that because the compiler is not aware of what your abstractions are. The compiler is only aware of what, what is core to the programming model. So it's a non-starter. It's not a good idea. I've been down this path. This was hard won wisdom. Any other questions or comments?
What's your take on I know some other blockchain project, they try to use concurrency control approaches like software transactional memory. So what's your take on this one?
STM is good. I actually like STM, especially if you have syntactic support. Again, if it's library based, then you have problems. But if you provide syntactic support for STM, it's not a bad approach. STM, however, is anti-availability, right? The problem with transactional models in general is, like, for example, if you adopt two-phase commit, it's basically an anti-availability protocol. This is why people began to look at relaxed transactions, so that you somehow relax some of the acid properties. So if you're trying to transactional models that don't deal with what is the fundamental exchange, like what is the fundamental transaction unit? What is the fundamental unit that you want to be transactional? So the thing that's interesting about the mobile process calculi is that they say data swap, right? I'm handing you data. That has to be transactional. And that has to be what's connected to how you can observe. That's the STM tends to go allow for things above that, and if it goes above that, then you have this. Then it starts to be then this notion of locking these higher level abstractions comes into play, and once you do that, then you start to have throughput problems. So it's really an impedance match kind of thing, where you want to get your locking connected to the right primitives. If the locking creeps upward to larger and larger chunks, then you have throughput problems. And so learning how to, having something that allows you to adjust that is the right way to go, because you want to tune what you lock. And the nice thing about the mobile process calculi is that you have channel-based access, so it allows you to tune what you lock. You can have a channel that's locking access to a whole other structure. So that's it's a particularly flexible kind of arrangement. right? So the lock is directly connected to data exchange. So anyway, that hopefully I've made it clear what the trade-offs are. But I really do believe in that STM has a significant value. It's just you have to be careful with it.
Yeah, and this is exactly what I did when I worked on Archain token. I was able to very quickly add locks at different levels in my code with Roland, of course.
Yes. Yeah, exactly. The channel-based access gives you this very flexible locking mechanism. Yep. Cool. All right, gentle people, that's all I have to say for today. Mike and I've been making cool progress on the test cases that we're doing for OSLF. So in particular, the whole Q category stuff. We went down several calculation paths for the power object for Q categories, and it looks like we've found one that it's working. And surprisingly, it uses the notion of trace. So that was a bit of an eye opener, but I'll talk about that next week. So with that, I'll yield back us 30 minutes of time. Thanks so much to everyone for your time and attention.
Thank you, Greg.
Ciao, ciao.
Thank you, everyone.
Thanks.